Welcome to FlightGlobal Focus, your essential podcast for trusted aviation insight. I'm Murdo Morrison, FlightGlobal's Head of Strategic Content in London. As Airbus considers its options for the design of a future next-generation single-aisle aircraft, one of the crucial decisions will be the structure and configuration of the wing. The wing offers huge aerodynamic opportunities for improving efficiency, and alongside the engines is one of the biggest levers available to lower fuel burn and reduce emissions. Airbus is investing heavily to explore how it can take advantage of cutting-edge materials and technology through a program it calls the Wing of Tomorrow. It's among Airbus's most significant research initiatives. And with me to talk about it is FlightGlobal's Air Transport Editor, David Kaminsky-Morrow.
Hello, Murdo.
Well, David, the name sounds very futuristic, but what exactly is Wing of Tomorrow?
Well, despite the name, Murdo, the Wing of Tomorrow is really more about the wing of next decade, if you like. It's a long-running research and technology effort led by the UK, not surprisingly, because the UK is the centre of Airbus wing production. And its purpose is to mature the technologies needed for a new generation of aircraft wings. And that's specifically for the aircraft which has this monumental task of eventually replacing the A320neo family towards the end of the 2030s. And Wing of Tomorrow focuses really on two very closely connected challenges. The first of which is to design a more aerodynamically efficient wing. And the second is to prove that this new wing can be manufactured and assembled at the high rates demanded by the single aisle market and at the costs which make it economically feasible.
Yeah, and you said it's long running. So when did all this start and who's funding it?
Well, the formal work under the Wing of Tomorrow banner has really been underway since the mid-2010s. And that's when the UK's Aerospace Technology Institute, which works with the British government to set out the country's aerospace technology strategy. That's when they provided the equivalent of some £220 million, about $300 million in public funding for the programme. And of course, there's also additional investment from Airbus and the suppliers that are going to support the work.
So what's at the technical core? What are they actually trying to achieve with the wing itself?
Well, the technical principle is really based ultimately on biomimicry. I don't know how much of a birdwatcher you are, but the wandering albatross has this ability to fly huge distances over oceans pretty much without the need to flap its wings. And that hugely efficient wing is what Airbus is interested in. And the central design philosophy of Wing of Tomorrow is fairly straightforward. If you increase the wing's aspect ratio by making it longer and more slender, but at the same time lighter, then you can help to reduce drag from vortices at the wingtips, and all that increases the wing efficiency. The wing structure itself is probably going to be built from advanced composites chosen for their strength and their stiffness as well as the lightweight. And the aim is to maintain the structural performance of current wings while achieving a meaningful weight reduction. The big problem with these broad wingspans isn't really in the air, it's on the ground, because airports have gate and taxiway constraints. And so an important part of Wing of Tomorrow is to research folding wingtips, something that Boeing is already incorporating into its 777X program.
Yeah, of course. And how's Airbus testing these ideas?
Well, Airbus is using 3 full-scale wing demonstrators, each of which is about 17 meters long. That's the equivalent of a 321 wing at the moment. And the last of those 3 demonstrators has just recently been completed. One of them is going to be mainly handling load testing up to destruction to validate its strength capabilities. And the other 2 demonstrators are going to be used for the technology and the industrial aspects. One of those is going to be a fully equipped wing, which will have all the systems and mechanics that are going to be assessed. And bearing in mind that Airbus is looking at about 100 different technologies from 40 partners to choose the ones that it's going to use for the future wing, not just things like fuel and electronics and control surfaces, but also the way all these are built and the way they all fit together. And that work is being done at Airbus's Filton Research Centre. The third demonstrator, and that's the latest one to be completed, is arguably the one that really needs to solve the hardest task, because the third demonstrator is called the run at rate wing, and that's being put up in the Broughton plant where Airbus carries out its wing production. And the run at rate demonstrator is designed to test whether the manufacturing and the assembly processes that will bring together the modular and simplified designs and the integration of technologies, composite structures, drilling, and so on and so forth. It's designed to see if it can support high volume output. Here's what the Wing of Tomorrow Programme Chief Sue Partridge had to say at the Farnborough Air Show in July.
Wing of Tomorrow is here to learn, and what we've learned is in some areas automation is really working well. In other areas, maybe a human being is actually a very efficient machine. So by testing, as we've built that third wing step by step, testing each of our assembly systems at the rate it will need to work at in the future, we've really been able to understand where the bottlenecks are, what the next phase of research needs to be, where we need to focus even more on automation, and where maybe we're going to look at a more of a manual process.
So the whole program is really geared to finding not just the promising technologies, but also determining where the snags might lie when it actually comes to building the wing.
Yeah, fascinating stuff, David. And obviously the wing has to be flight tested. How close is that to becoming reality?
Well, that part, as you say, that's critical. And that part became clearer during the Farnborough Air Show. Airbus is going to build full-scale wing extensions for an A321neo test aircraft. And those extensions are going to be several meters, maybe 4 or 5 meters long. And although they're just proxies and they won't actually fold, they will be simulating and they'll behave like a fully deployed folding wing. And that will allow Airbus to gather real flight data on the behavior of a broader span and examine things like handling and flutter, wing loading, and other performance aspects. This is going to be a 3-year flight program, and the flight testing should start in Toulouse in the second half of next year. The Wing of Tomorrow's technology lead, Richard McPherson, was also speaking at Farnborough, and he said this.
Well, we aren't in the air just yet. So we are using advanced digital simulation and also we've performed intensive wind tunnel testing to really evaluate and optimize these different devices. We have already manufactured components for the first extension device with our partners in the supply chain, and we are about to start assembling in Filton in the Wing Technology Development Centre. So a really proud moment for the programme and for all the teams that have worked on this. At Airbus, though, nothing leaves the ground without being rigorously tested. And long before these extension devices will take flight, we will already know exactly how they will behave when we take them into the skies.
It does sound like this programme is gaining momentum. How does it fit into Airbus's broader plans for a next-generation single-aisle aircraft?
Well, Wing of Tomorrow is one of several technology streams feeding into the next generation single aisle concept, along with other key parts such as the power plant. I mean, Airbus is potentially looking at putting open fan engines on this aircraft through the CFM RISE program. And the wing research obviously has to take the effects of that into account. So there's a lot riding on the next-gen single aisle. It's poised to take over from Airbus's best-selling aircraft from second half of the 2030s, and they're very big tires to fill, if you like. And with that comes a lot of risk. They're having to consider and validate the structural performance of large composite wings over a full range of flight loads. Folding mechanism introduces additional complexity to that, such as weight, reliability, certification issues. And there's still a lot of questions to be answered about manufacturing rates of composite wings. especially given that the A320neo family wings are primarily built of aluminium, which is a much less demanding material.
So that's wing of tomorrow. But from a broader industry perspective, why does this matter beyond Airbus?
Well, single-aisle aircraft, as I know you're fully aware, they dominate the global fleets, and they're going to continue to do so for decades to come. So any meaningful reduction in fuel burn and emissions obviously has a large cumulative effect. The manufacturing technologies being developed, high-rate automated composites, greater integration, digital process control, they're also probably going to influence the wider aerostructure supply chain. And Wing of Tomorrow, being spearheaded by the UK, obviously has substantial implications for the long-term competitiveness of the British aerospace sector.
Excellent. So many different avenues to go down there. And thanks very much for bringing us up to date on Wing of Tomorrow, David. Thanks for joining me.
Yeah, it's been a pleasure, Murdo. Thank you.
You've been listening to FlightGlobal Focus, which is a production of FlightGlobal with audio editing by Lucy Johnson. If you want to get in touch with us or for commercial opportunities related to the podcast, please email podcast@flightglobal.com. Listen, rate, review and subscribe wherever you get your podcasts. Join us again next week for more in-depth analysis covering the latest developments in airlines, defence and aerospace. I'm Murdo Morrison. Join us next time for FlightGlobal Focus.